Next, and he's sitting across the table from me in his loudest play.
What's up, guys? I'm Ryan Thaxton, and I need 8 points. So today I'm going to do problem 10.2, which is a Carnot vapor refrigeration cycle. And the working fluid is refrigerant 22. The evaporator temperature is 36 degrees C, and the condenser temperature is negative 30 degrees C. So, starting off, just knowing what a Carnot vapor refrigeration cycle is. TS diagram. It's like a rectangle or a square. The first process, second process, third process, fourth process. And you can think of this as evap, and this is condenser. Alright, so the things that we're going to do today, we're going to find the rate of heat transfer, through the evaporator. We're going to find the work net, the coefficient of performance, beta, and the refrigeration capacity in tons. Alright, so now that we know the refrigeration temperatures, we know that this is saturated, saturated vapor, and this is saturated liquid. So, we can go and find the H values. And the H values for H2 is 260.11 kilojoules per kilogram. And for H3, it's 89.29 kilojoules per kilogram. I think it'd also be a good idea to find the entropy. So, the entropy value for 36 degrees sat vap is 0.8790. And for S3, it's 0.3265. Now, if you go back up to this TS diagram, you'll see that it's isentropic from 1 to 2 and from 3 to 4. So we can find that S1 is equal to 0.8790 kilojoules per kilogram times Kelvin, and S4 is equal to 0.3265 kilojoules per kilogram times Kelvin. So, with that information, we can find the qualities for T2 for T1 and T4. So, I'll do that right. Whoa, look at that. Just magically appeared. Alright. Now we're going to find the enthalpy at H1 and H4. So, H1 equals 231 quality times 237.78 minus 11.0. And that equals 213.54 kilojoules per kilogram. H2. Nah, H4. H4 equals 11.00 times over 7. Quality X4. H4. If you do the math for all that, H4 equals 79.19 kilojoules per kilogram. Alright. So now that we have all that, we can find the work net. Alright. So, just kidding. Heat transfer. Through eval. So, if we go back up here, you see the heat transfer through evaporator. It's 1 through 4. It's actually 4 through 1. It's flowing that way. So, Qn goes m dot times H1 minus H4. Now, if we go back, actually in the problem, we're given m dot. M dot equals 10 kilograms per minute, which equals 0.1667 kilograms per second, right? If you divide it by 60. So, Qn equals 1667 times H1, which is 213.54 minus 79.19. Alright? And that equals 22.40 kilowatts. Remember guys, always box in your answers or you'll get 50 points out. So, next we find the work net. And the work net equals m dot times the work in the compressor minus the work in the turbine, which is equal to m dot times H2 minus H1 minus H3 minus H4. Alright, so now we're going to find the coefficient of performance, COP beta. Beta is only in the refrigeration cycle. Alright, so beta equals Qn over work net. Now, from the other things, we already found work net. We already found Qn. So, put that in. 22.4 over 6.08. And that equals 3.68. No units. Now finally we're on the last part of the problem. Find refrigeration capacity in tons. Now the refrigeration capacity is actually the QN. And so we're just converting that to tons. Well, I just figured, hey, I'll just do it over again. No problem. Minus 9.19. And that equals 1,343.5 kilojoules per minute. Now, if you look at your tables, you will see that 1 ton refrigeration one ton of refrigeration equals 211 kilojoules per minute. Now all we gotta do is just divide 1,343.5 kilojoules per minute divided by 211 kilojoules per minute. And that will equal to 6.37 tons. And that is the end of my problem, guys. Get that extra credit. And the next problem, I will be doing a 9.21. See y'all later.